electronic configuration. We were trying to write out the electronic configuration as per the Bohr's model of atomic theory. Okay, and we understood that during the Bohr's model of atomic theory, over there we understood that electrons can revolve around a nucleus in fixed or stationary orbits. Until they revolve in their fixed or stationary orbits, they do not radiate energy. So electrons do not radiate energy when they are in their stationary orbits, right? So we were done with the writing of the electronic configuration, and the rules which were to be followed while writing the electronic configuration. There are certain rules which are to be followed. That first of all, you have to take care that shell of lower energy will be filled first. The shell of lower energy will be filled first. Okay. Then only the higher energy levels can be filled up. Also, no shell can contain an electron. No shell can contain an electron greater than its capacity. So a shell cannot contain electron greater than its capacity. Suppose it has the capacity of holding 2 electrons only, so it will hold 2 electrons only. It cannot hold more than 2 electrons. So this is the meaning by this, that no shell can contain electron greater than its capacity. Okay. Also, outermost shell can be either fully filled or can be either fully filled. So outermost shell can be either fully filled or it can have or will have 8 electrons. That is, or will have octet configuration. Or octet configuration is stable.
Sir,
Yeah. Okay. Let me list this in proper language. So outermost shell can have can is stable. It is
sir, what
stable.
is octet configuration?
Octet configuration means holding of 8 electrons.
Okay.
Okay. Stable with octet configuration. It is stable with octet configuration or fully filled configuration. Fully filled electrons. So this is what can be there in the outermost shell. There is no other alternatives. So keeping these points in mind, we will be filling up the electrons in any shell. Okay. For example, in the last class, I had told you to fill up the number of electrons uh, in various shells of sodium, potassium. Then we also saw filling of the electrons in the. We also saw the filling of the electrons in. We also saw filling of the electrons in those ions. Okay, we discussed with the ions also. Okay, just wait. कितना देर लगेगा? Hmm? Only the small thing. Okay, see. So these are the points. For example, suppose I want to fill out the electronic configuration of potassium, which has atomic number 19. Okay. So K stands for potassium. It has atomic number 19. This K is not your shell number. Okay. If you look up the shell, so arranging the number of electrons is K, L, M, N. Now K shell has the capacity to fill out 2 electrons. It has the capacity of filling 2. L has 8 and M has the capacity of 18 electrons.
16, 18, 18, yeah, then
And N
32.
has the capacity of 32 electrons. So if in this way I fill out 19 electrons, so there will be 2 electrons in the K shell. There will be 8 electrons in the L shell. This adds up to 10. We still have 9 electrons. Okay. But see here, the M shell has the capacity of holding 18 electrons. So therefore, 9 electrons can be easily accommodated in the M shell. Right?
But
We can
doesn't
accommodate
Amsterdam have like some exception, like for gases or something only it will hold up to 18?
It's the
this.
octet.
Okay. So see, if I fill up here 9 electrons, it violates my octet rule. Our octet rule says that the outermost shell is stable with octet configuration or fully filled electrons. So either the outermost shell should be fully filled or it should have 8 electrons. Okay. So here, since if I allot 9 electrons to the M shell, so in this condition, the M shell is not stable. The outer atom will not be stable, and therefore M will not be able to hold 9 electrons, and hence it will be holding only 8 electrons. Okay. So it will hold out 8 electrons only. One of the remaining electrons will be passed on to the N shell. Okay. Now N shell will have the filling of 2 electrons, and then after that again M shell can be filled up. So this was regarding potassium. Similar rule is followed for calcium also, whose atomic number is 20. So for calcium, again, if you go on filling about the electrons, it will be 2, 8 in the L shell. And for the M shell, again, you have 10 electrons. So we cannot accommodate 10 electrons in the M shell. However, it has the capacity of 18, but still we cannot allot 10 electrons in the M shell, right? So as if
Okay.
I allot 10 cells, 10 electrons, so it is violating my octet rule. So therefore, it will be either 8 electron, it will have 8 electrons, and the remaining 2 electrons will be passed on to the N shell. Okay. Now after calcium, if you go on making suppose for atomic number 21, that's scandium. So now it will remain the same, and first this M shell will be filled. So for scandium, whose atomic number is 21, so filling will now continue in proper way like this 2, 8, and now from 8 it will increase to 9, it will remain 2. So this will now go on increasing from 9 up to 18, and when this is fully filled, then again filling of the n orbital will be done. Okay. So is this understood how we are filling up the number of electrons?
Yes.
Okay. So is Siddharth present? No, Siddharth is not present. All of you turn on your cameras.
So,
Everyone keep your cameras. Yes.
sir, if you have nickel, sir, like the element, the 28th element, so they say that it has a valency of 2. But then if we write like the electronic configuration, we can write 2, 8, 18, right? So why does it have a valency of 8, like 2?
Okay. So for those concepts, you will be getting into the concept of the higher orbital theory. Okay. With the orbital theory, which was see, even this Bohr's model is it was not, it had certain drawbacks. Okay. So the drawbacks of the Bohr's theory, they were explained by the quantum mechanics. And those structures or those abnormalities, they were explained on the basis of the quantum mechanics. So quantum mechanics is not in your syllabus, so you need not worry about them, right?
Okay, sir.
On the basis of quantum mechanics, you will be studying about orbitals. Okay, so that is a part of class grade 11. So no need to worry about the orbitals. Okay,
Okay, sir.
so that is why you shall be able to write the electronic configuration up to the element of atomic number 20, that is calcium. After calcium, no need to worry about how to write out the configuration. Okay, then you shall be able to write down electronic configuration of ions. For example, if I want you to write down the electronic configuration of K plus, I want you to write down the electronic configuration of O minus 2. Okay. I want to you to write the H S minus 2. So can you write down electronic configuration of K plus?
2,8,8.
2,8,8. As this electron has been removed, so it will only have 18 electrons, which will be 2,8,8. In the similar way, oxygen, it will also have, it has accepted 2 electrons, so their total number becomes 18. Oxygen originally has 8 electrons only, so now it will have 10 electrons. It will be 2, 8. So again, you can see why oxygen always gains 2 electrons, just to attain its stability. Okay. Why ions are formed? Ions are formed to have the stability of the atom, as outermost is stable with octet configuration or fully filled electrons. Okay. So all the elements, they want to attain the octet configuration, or they want to attain the configuration of fully filled state. Whatever orbitals are there, they shall be fully filled. So if you look up here, like suppose I discuss for hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So I am discussing now these elements. So hydrogen is number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If I write their electronic configurations as K, L, and M, so you will have your 1, this will be 2, this will be 2 and 1, this will be 2 and 2, this will be 2 and 3, this will be 2 and 4, so this will be 2 and 5, here you will have 2 and 6, this will be 2 and 7, and this will be 2 and 8. Okay. So understood how, first of all, everyone tell me that have you understood how I have written the electronic configuration of all these elements? Rikshit, have you understood?
Yes, sir.
Okay, Rikshit. So we have understood all this. Now, from these electronic configurations, whatever electronic configurations are written, see, if we consider the last point says that outermost shell is stable with octet configuration or fully filled electrons. So if you observe for hydrogen, the outermost shell is K shell.
Yeah.
Okay, since outermost shell is the K shell for hydrogen, and it has only 1 electron, but the capacity of the K shell is 2, right?
Yes, sir.
Okay. So how many electrons does, how can hydrogen satisfy its complete its outermost shell?
It has to gain one more electron.
Yeah, if hydrogen gains 1 more electron, so hydrogen will have a completely filled orbital or completely filled shell. So in this way, we can define the valency of an atom. So here we discuss with 2 other words, that is valence electron and valency. Okay. So again, Chavan, Aman, Neha, all your cameras are off. Okay. So what are valence electrons? The electrons present in the outermost shell. Okay. Electrons present in outermost shell. Electrons present in the outermost shell are called valence electrons. Okay. So what are the valence electron for hydrogen? Neha, what are valence electrons for hydrogen? Neha,
Sir?
are you there? What are
Yes, sir.
valence electrons? What are valence electrons for hydrogen?
Zero, sir.
Valence electron means how many electrons are present in hydrogen atom, outermost shell of the hydrogen atom. So if you see the outermost shell of the hydrogen atom, how many electrons are present?
One.
One electron is present in the outermost shell of the hydrogen atom. Okay. So in the outermost shell of the hydrogen atom, here you just have one electron. So I will say that hydrogen has one valence electron. What are the valence electron for helium? What are valence electrons for helium? Siddhisri, what
Two,
are
sir.
valence electrons? Siddhisri, what are valence electrons for helium?
Sir?
Yeah, what are the valence electrons for helium? First of all, were you there in the class? Siddhisri?
Yes, sir.
Siddhisri,
Yes, sir.
were you there in the class?
Yes, sir.
So camera is always off. Can you
Sir,
keep the camera on?
it is stopped, sir.
Okay. Harini,
Yes, sir.
why your camera is off?
Sir, I'll turn it on.
Sir, can you be a bit louder? Your voice is kind of low.
What happened?
Your voice is kind of low, sir.
Okay, it's unaudible.
It's audible, but it's very low, sir. Can you talk a bit louder?
No, I don't think. Harini, is it audible and clear?
It's audible, sir, but now it's fine. Now it's fine.
Yes, now it's obvious.
Okay, see, the number of the valence electron, that means whatever is the Siddhisri, can you tell the number of valence electrons in helium?
Sir, everyone can look at the screen at least. Change the.
One.
One. For helium, how you say that the valence electron is one? Okay. Pranay, how many valence electrons are there for helium?
So there are two valence electrons with the valency zero.
Yeah. Rikshit? Rikshit? Rikshit, where are you?
Yes, sir. Yes, sir. Yes, sir. Hello. Can you hear me?
Yeah. Keep your camera on. And how many valence electrons are there with boron?
Sir, the valence, sir. Valency.
Valence electron. how many valence electrons are there with boron?
Sir, since in the last shell it has 3, and they're supposed to the octet is 8, sir. So the valency will be 3 only, right?
See, these are the two words which we get confused with. The word is valence electron and
Sir,
valency.
so but then at the outermost shell, it's called valence electrons, right? So it should be 3 only, right?
No,
Yeah, it should be
valence
3.
is 3.
Oh,
Valence
I'm sorry.
electron is 3.
Oh,
Both
sir,
are
which one,
3.
sir?
See, valence electron is 3. Valence electron means electrons present in the outermost shell are called valence electron. So since
Which
boron
one did
has
you ask?
3 for boron,
Yeah, 3 is the answer, right?
yeah. So for boron there are 3 electrons in the outermost shell. Therefore, boron has the valence electron 3. Nitrogen has 5 valence electrons. Okay. And if we talk of valency, so valency is the number of electrons that can be gained or lost. That can be gained or lost to complete the octet. Since the element has to complete the octet, so therefore there are two ways. Either the element or either the atom can gain electrons or the element can lose electrons. Okay. So for hydrogen, it's both way simple. Hydrogen can either gain one electron or it can either lose one electron. Both way it's easy for it. Both way it's getting the same thing. So therefore hydrogen will form two types of ions. It will form ion as H plus 1 or H minus 1. Both types of ions can be formed by hydrogen.
Yeah, understood, sir. This is.
Okay. So when hydrogen forms minus 1 ion, so it gains one electron and it forms the hydride ion. Its valence is fulfilled to 2. If it loses one electron, so then also it's free and therefore it forms the hydrogen ion H plus. So both are true. For helium, as we observe that the capacity is fully filled. For helium, the two electrons, their capacity is of 2 electrons and it is fully filled. So therefore no electrons are required in the helium. Helium has a valency of 0. Okay. If you see lithium, so lithium has electronic configuration 2, 1. Okay. Lithium has the electronic configuration of 2, 1. So therefore, lithium will have the valence electron 1 and its valency will be what will be the valency of lithium?
1.
1. So will it lose electron or gain electron?
They will lose electron.
Yeah, lithium will lose one electron and it will form lithium plus 1. Beryllium will also be able to lose 2 electrons and it will form beryllium 2 plus. Boron will have a valency of 3 and it will form an ion of plus 3. Carbon, it can go either way. Yes.
Sir, in lithium you put +1, and then in beryllium you put 2 plus, and then again you put +3, right? What's the difference?
Okay, boron. This is beryllium, this is boron.
No, sir. I mean, like for one you put 2 plus, and the other one you wrote +3. So why you
Okay.
like writing
Okay,
one?
so both way it's correct. Either you can write it plus 3 or plus 2.
Okay,
Okay.
sir.
Okay, so it's not a much difference. They are just representations. Okay, so you can write plus 2 and 2 plus, they will be treated similar. So boron is plus 3. Carbon, it can have both. It can either gain 4 electron or it can lose 4 electron. So it will have a valency of plus 4 and minus 4 both. Now nitrogen, it can gain 3 electrons. So it has a valency of 3 and we will write it as minus 3. So nitrogen will form a nitride ion with the valency of minus 3. So N minus 3. Oxygen has 6 electrons and it would require 2 more electrons to complete its octet. Okay. So oxygen will form an oxide ion with valency -2. Okay. Neha? Neha,
Yes, sir.
what is the valency of neon? What is the valency of neon?
0, sir.
0. And for fluorine?
Fluorine, it's um -1, sir.
Okay, fluorine valency is 1 and it will form a fluoride ion with valency -1. Okay. So it will form a fluoride ion F-1. So I think now you can predict about the valencies and the valence electron.
Yes, sir.
Okay. So anyone has any doubt in writing the electronic configuration or predicting the valence electron and valency? Aman,
Yes, sir.
any doubts?
No, sir.
Okay. So Aman, can you write down the valency of can you write down the configuration of this one? Argon. Write down the everyone write down the electronic configuration of argon. What is the atomic number of argon?
Sir, 18, right?
18. Argon has the atomic number 18. So everyone write down the electronic configuration of argon. Write its valency and oxidation state.
Sir, can I tell?
Yes.
Sir, it's 2K, 8L,
Two-
8M.
Yeah. It's
The
2K, 8L and 8M.
valency is 0.
Valency is 0. Its valency is 0. So now it's okay. Shall we move further now?
Yes, sir.
Okay. See, if you are interested in the chemical properties of an element, we are interested in the chemical properties of element, that how an element reacts. So the chemical properties of the element, they are dependent on the number of electrons and the electronic configuration, right? So this is a common thing, that if you are asking for chemical properties, the chemical properties of a function, chemical properties depend on number of electrons and electronic configuration. Okay. So chemical properties of any atom, it depends on the number of electrons and their electronic configuration. Also, the number of electrons depends on the number of protons, right? Do you agree with this? That the number of protons depend on the number of electrons depend on the number of protons.
Yes, sir. So the number of electrons and protons are the same, right?
Are the same, okay? Depend on number of protons. So what is important inside the atom is protons. If you know the number of protons, so you can predict its number of electron, you can predict its chemical properties, everything can be predicted about the atom, right? So we will be discussing this number of protons is very important for us, since atom overall is neutral. We know that atom is neutral. So therefore, for this reason, the number of protons should be equal to the number of electrons. in a neutral atom. If the atom is neutral, so if the neutrality is maintained, then the number of protons should be equal to the number of electrons. Right? So, as you know that the protons do not participate in a chemical reaction, or nucleus does not participate in a chemical reaction. It's the electrons which participate in a chemical reaction. It is the transfer of electrons which occur from one atom to the other in a chemical reaction. Okay. So therefore, all the properties, they are dependent on the number of protons only. So for this, if you take up any atom, we can predict it. Now, these three terms are defined on the basis of the number of protons and the number of neutrons. First one is your atomic number. Okay. So atomic number is the number of protons. Okay. It is the number of protons present in an atom. The number of protons present in an atom is called atomic number. Okay. So that is the atomic number of protons present in an atom. You have another term, that's mass number. Mass number, it represents the number of protons plus the number of neutrons. The sum of the protons and neutrons represents the mass number. That means you can say that it represents all the mass of the atom. Okay. Mass number represents all the mass of the atom. Okay. So atomic number
Sir,
and mass
how
number.
how can we know the mass number is correct here?
How can we know the mass number?
Yeah, is there like a formula to find out mass number?
See, that is the number of protons plus number of neutrons. The sum of the number of protons and the number
How
of
do you
neutrons.
find the number of neutrons?
Yeah.
How do
Sir,
you
how
find the number of neutrons?
number of neutrons?
How do you
Yeah,
find the
zero
number
times.
of neutrons? Okay. See, first of all, the mass number is calculated using practical methods. Practical methods means the mass of the atom is calculated. Since the electron is almost massless, electron does not have a mass. So therefore, the mass of the atom is calculated. It is made up. It is measured in the laboratory. And from the mass of the atom, we can compute the atomic mass and the mass numbers. Right? And it is written symbolically something like this. Suppose I write here an element X. Here at the bottom, whatever I write as A, and I write on the top as B. So whatever is written on the top, that is the mass number. Whatever is written over here at the bottom, that is atomic number. So suppose if you have an element X written like this, suppose it has 7, 15. Okay. So what is the atomic number of this element? What is the atomic number of this element?
Sir, is it nitrogen? Sorry. Sir,
Proteins.
phosphorus, sir?
No, I'm asking atomic number. What is the
Oh,
atomic
okay.
number?
The nitrogen.
7.
7. By these symbols, you can guess that whatever has been written over here, that is the atomic number. So its atomic number is 7. Its mass number is 15. And how many protons does it have?
7.
7 protons. And how many neutrons are there?
15 minus 7.
15 minus 7. That would be 8 neutrons.
8. Okay.
Okay. So Neha and everyone can calculate this. Can everyone get this? Everyone has understood?
Sir, can you give another example?
Okay, for this one, chlorine 17 and 35. What is the atomic number? Also, you have chlorine 17 and 37.
What are we supposed to find?
Yeah.
What are we supposed to find?
Again, the same thing, atomic number, mass number, number of protons and number of neutrons.
Okay, so
You have to tell what is the atomic number in both the cases. For both the chlorine. Tell atomic number, mass number, number of protons. And number of neutrons. Okay. So, I think now Prince will answer. Prince, what is the atomic number for this chlorine 1735?
Sir, 17.
17. What is the mass number?
Sir, 35.
35. What is the number of protons?
Sir,
Yeah. Try out. What is the number of protons? See the previous example and tell.
sir, 17.
Yeah. Number of protons are 17. And how many neutrons are there?
18.
18 neutrons. Very good. Okay. So for this one, for chlorine 37,
Sir, 17.
okay. 17, atomic number is 17. What is the mass number?
37.
37. Number of protons?
17.
17. Number of neutrons?
18.
Okay. Is it 18 or 20? Check out once more.
Sir, 20.
20. Remember the formula that mass number is equal to the number of proton plus the number of neutron. Okay. So I think now up to now everyone has understood. Siddhisri? Siddhisri, have you understood?
Yes, sir.
Okay. Now see, the atomic number is represented by the number of protons. Here, as we know that the number of protons, it represents the atomic number. So therefore, from these, we can have the atomic number equals to 17. Atomic number and mass number we can calculate. We can also compute the number of neutrons and protons. Another word that is you will also hear about atomic mass. So atomic mass and mass number, they are the same thing. Okay. Atomic mass and mass number, they are the same things. Okay. Both include the word mass. Remember that way. So atomic mass is the mass of the atom and mass number is the number of protons and neutrons. Okay. So both are same. Both will have the same value. Now, the properties of an element, they depend on the number of protons. See, here we have already discussed that the chemical properties of depend on number of electrons and electronic configuration, and number of electrons depend on the number of protons. So, you can indirectly say that all the chemical properties of an element, they depend on the number of protons and not on the number of electrons, not on the number of neutrons. Can we say that? That chemical properties of an element depend on the number of protons, okay, and they do not depend on the number of neutrons. Aman,
Yes, sir.
will the chemical properties depend on the number of neutrons?
No, sir.
Why no? Rikshit, why do the chemical properties not depend on the number of neutrons? And why it depends on only on number of protons?
So can I tell?
Sir, is it because
Hmm.
it doesn't have positive or negative charge?
Yeah, it does not have any charge. Since a neutron does not have any charge, so therefore it cannot help anyway in a reaction. Okay, so therefore number of neutrons does not affect the chemical properties of an element, and hence if an element has atomic number 7 and let's say it has mass number 14, an element again we have something Y, it has atomic number 7 and it has the mass number 15. So can I say that both of them will have the same properties? Rikshit?
Yeah, sir. Hello.
Yeah. So will they have the same properties or different properties?
So they'll show different properties.
Okay. So why they will show different properties? So why these two atomic species will show different properties?
Sir, because their mass number is different.
So mass number is different is due to the difference of the number of neutrons, right?
Can I tell?
So
Yeah.
yeah, I'm not pretty sure
No,
about my answer.
wrong.
Mhm.
It does not change the chemical properties because the
They
number of
do
atoms are only varying.
see in both of them you can see the atomic number is same. That means the number of protons is same. Okay. So they just their number of electrons will also be same. They will have a different number of neutrons. So the properties will not be affected. It's something like this. If you observe, let's try to understand this. This is very important to understand to remove all your doubts from it. I want you to have zero doubts from this regarding isotopes and isotopes. So suppose if you have these nuclei, okay. So these are the two nucleus and you have that electronic shell around it. Suppose if you have these shells around them. Suppose this is one of the shells. So in the similar way, both of them are having the shells like yes. Okay. So these are the two sets of species X and Y. What is the difference between them? They have the difference of the number of neutrons. It has the difference of the number of neutrons. Let's see. I'll also write their electronic configuration and then show you. See, this is your X and this is Y. In the X, you have here 7 protons and 7 neutrons. You have 7 protons and 7 neutrons. Here you have 7 protons and 8 neutrons, right? This is how they look like. It has the atomic number, it has the mass number 14. So if you sum up them, it will be equal to 14. This one has the mass number of 15. So if you sum up them, their sum will come out to be 15. Okay, see here. Now, if you find out the number of electrons from here, so both of them are having 7 electrons. So there will be 2 electrons in the K shell. The remaining 5 will be in the N shell, in the L shell. Okay. So both of them, they are quite similar to each other. Yes. See, both of them, they are having the same number of electrons also. They are having the same number of protons also. The only thing is different is that they have a different number of neutrons. And we have studied that the number of neutrons does not affect the reactions, right? As the number of neutrons are neutral, so therefore they will not be affecting the reaction. So these two, they do not affect the reaction, and hence they are called as the isotopes. They are called as isotopes of an element. So isotopes have similar properties, right? Let us define what are isotopes then. Again, Aman, your camera is off. Every time I will not tell everyone to keep your camera on, keep your camera on. From the next time, if I see anyone's camera off, I will just inform in the group. There is no other alternative. Please, if you want to keep your camera off, so either inform in the group that your camera will be off today, or for whatever reason it is. So what are isotopes? They are atomic species. They are atomic species with similar mass number, with same number of, with same atomic number but different mass number. Okay. So these two species, X and Y, they are isotopes. And actually, they are the same elements since they are showing the same properties. So therefore, we represent them with the same atomic symbol, right? So we can write nitrogen like this. We can write, they both are nitrogen. So there are two varieties of nitrogen. You have nitrogen 7, 14. You have nitrogen 7, 15. In the similar way, you have two varieties of carbon also. There are two varieties of carbon, and the two varieties of carbon are carbon 12 and carbon 14. So these are also isotopes of carbon. Okay. So what are isotopes? Prince, what are isotopes?
They are atomic species with same atomic number but different mass number.
Yeah, they are the atomic species with same atomic number but different mass numbers, right? So such species, they are called isotopes. Will they have similar chemical properties or different?
Sir,
Prince?
they'll have similar.
They will have similar chemical properties, right? So isotopes will have similar chemical properties. Okay, they will be exactly same chemical properties, and hence they are the same element. Now, after the atomic isotopes, we have another words that isotones and isobars are also there. We will discuss about them in the coming up later classes. I hope everyone has understood up to the concept of the isotopes. Okay. There are three isotopes for hydrogen also. They say here, for hydrogen, there are three isotopes. That's hydrogen 1, 1, hydrogen 1, 2, and hydrogen 1, 3. These are the three isotopes of hydrogen. This one is called as protium. This one is deuterium. And this one is tritium. So you have protium, deuterium, and tritium. These are the three isotopes of hydrogen. How many neutrons are there in a protium?
Sir, can you repeat?
How many neutrons are there in protium?
Sir, are there even neutrons in it?
Neutrons. How many neutrons are there in protium?
Do they even have any neutrons?
They don't have any neutrons. As atomic number is also 1 and mass number is also 1. So if you subtract 1 minus 1, it would be 0. So they have 0 number of neutrons. Okay. So we'll continue our discussion in the next class. Bye everyone. Good night and see you in next class. Okay, bye.